I was going to my dad saying, I can hijack kernel 2.6 system calls. Look, I can do that. And he always went, get a life. Then I showed these kind of pictures to him, and he was, oh, you can do that? You're cool. Your job is cool. So we're not doing any software research anymore. We're just sticking with cars and, our thing because it's so cool. So, and you get the chicks too. I mean, would you ever get a chick by hijacking system calls? I don't think so. Other funny messages. Bullfight. So when I first saw this, I dream about this story. Like you got European community meeting, like people, all the different countries in EU, discussing about what events we want to do. And I think it went this way, like Spanish people went, we got those, please bullfight. Because there's no other reason for that. Delays due to parade. You can even get boxing match. So you can put a boxing match on a highway. But think about it. In Italy, you get an accident, then you get a boxing match. That makes perfect sense. You cannot have a pony. That's sad. So, having said that, implementation issues. So there are some so you can do that. It's a standard. Satellite navigation system supports that. So you can play and do whatever you want. But there are also some implementation issues that makes this thing much easier. So the PI code is not at all associated to the frequency. So when we first tried this, we wanted to put the matching PI code for a specific frequency. If your PI code is like 666, it works. It's actually not being looked up at all. Some messages like total cancellation, so there's like a broadcast message where you can cancel all the different messages. It doesn't work. But mobile phones. But what you can do is you can delete all the single messages. So you can also do a denial of service thing. So I see a message with a sniffer, I cancel it, which just works by sending a message with a special event code on that same location. You cannot have two messages on the same location code. You can only have one. So you can cancel the previous messages, and then they're going to see nothing, okay? The broadcast message is not honored, so the standard allows a broadcast message that will pop up no matter what. Okay, so what we wanted to do is send terrorist incident and having that popped up no matter what, but it doesn't work. The diversion bit is ignore most of the times. You put diversion to 0. If it's an accident or a queue, some navigation system, they're going to pop up the message anyway. Okay. So we expect our navigation system to have the same issues. Of course, we didn't have time to test more than 2, but it's as usual, we don't think they support a protocol very, very well, okay? So I mentioned to you that it is an encryption for RDS TMC messages, but it's not really an encryption. It's just discrimination. So they built this standard because some vendors went, okay, so we want to sell these services. So you can understand by the very nature of this kind of broadcasting, you get a message over FM, you're going to see that. There's no way you can sell that unless you do something funky. So what they did, they encrypt the location code and only the location code with a specific location table which is not supported unless you pay. So you have to pay for DVD with that location table and then you can access the messages. And they do some kind of encryption on the location table 16 bits code. And this almighty encryption is bitwise operations. So as you can understand, if you know even small basics about cryptography, this is not encryption at all. So you can just sit there, sniff the traffic. Okay, I get this. You can see on your terminal where the location is. You apply a function, and then you can decrypt and get a service key. But actually, you don't care, because for injection, you don't care about encryption. This is only for decoding real messages. If I want to inject, since I can sniff your messages, and it's plain text, and I can see your location code, it's encrypted, I don't care. I will send a terrorist incident with that location code, and it's going to work. Okay? So this is just for a poor man discrimination. It's not for encryption at all. Okay? So it's not relevant at all. So, to wrapping up things, can be trivially injected. Drivers don't tend to have any security awareness. I mean, if you're using a computer, now you know you can get viruses and stuff. If you're driving a car, would you ever think that you can get something like this on your satellite navigation system? I don't think so. It's not the end of the world. This is a very widely used protocol, but it's still up to the driver, except for that scenario I show. But we want this work to be a big warning for future systems. Please do some form of authentication if you're going to send wireless data to your car. Also because this opens up all the possibilities of doing fuzzing and all kind of things to your satellite navigation system. So this is a very, very small data set that you can play with, and it's all binary, and most of it is decoded by circuits, okay? So we tried sending funky messages and to fuzzy, but we didn't get enough luck. What you can do is you can send lots and lots and lots of messages, and then your terminal gets very, very slow, okay? But if we're going to increasingly use this kind of system, it's an open door to, you know, a software that's running on your car. And on my car, the satellite navigation system also controls the radio, controls climate control, and all kind of things, okay? So they should be very careful with that. Also, these technologies have a very long lifespan. I'm not going to change my car because someone found that I can inject TMC messages. I'm not going to do that. And also, I don't think they're going to patch my satellite navigation system because of that. I mean, it's hard to get people fixing my car for normal issues, not to mention security problems, okay? So, and this is a very relatively old technology. It uses RDS, which is very old, okay? And it's been phasing in this year in Australia, okay? So, they should be very careful with these kind of things. So we got official response by the people developing this protocol. And it was very, very funny. So let's read the response together. So first of all, the article title was Hacking TMC Unsuccessfully. And I was, no, we did it, but okay. The first and overriding statement that should be made is that transmissions of this type are directly analogous to pirate radio broadcasts, and certainly will, in the case of Europe and the US, contravene each country's respective broadcasting legislation and laws. Oh, thank you. You're telling me that this is illegal. I'm sure it will stop everyone doing this. Oh, killing people is illegal. Problem solved. So that was a very nice clarification. There is a chance that a false message could be decoded, but a degree of knowledge would have to be gained on parameter of the message being coded. Hello, I can decrypt your messages. I know everything about the standard. I can inject whatever I want. The random use of any location code will result in a randomly located event. We don't use random location code. We got a location table. We know exactly where to place the code. Also, random choices of event codes may not cause the terminal to react. We are not using random events. We're using specified codes. And then, I don't know, if the transmission is on a different frequency, it is very unlikely that the terminal will ever tune to the false service. False. This is because this frequency will not be either in the main AF list or the secondary AF list broadcast in any of the tuning variants of the TMC data. FUD. This is the only way I can describe that. It doesn't make any sense. If the radio can do that, I can do that. It's as simple as that. There's no magic involved. There's no encryption involved. It's just a friggin' antenna and FM transmission. I can do that. The last one is the most hilarious. Service providers and broadcasters, I am sure, have many protection mechanisms and processes in place to prevent any legitimate access to their service with their infrastructure. Faith manages. So you can read their full response here and our reply there. So you make up your own mind on that. So the future. TMC is also supported on digital radio. It's harder to inject because you need more software stuff and more hardware stuff. But same thing. It's still possible. It's not encrypted. It's not authenticated in any way. It works. Another standard, TPEG, Transport Protocol Experts Group, is the new standard designed for replacing TMC. It supports encryption, but they don't say what kind of encryption you should use. Like the standard is, we can support encryption. This is the bits you can use, and that's it. And it's not mandatory, so it's basically the same thing. There's one new project which is called GST. It's a global system for telematics. It's a huge project backed up by BMW and all kind of people. So what they want to accomplish is like BlackBerry for cars. You are in the car, you put your credit card in the car, and you access all kind of services, including traffic messages. It is going to be encrypted with PKI and all that kind of stuff only because you have a credit card. Okay? So as they were saying in another talk, encryption is driven by commercial intent. But still, this is going to be much harder to hack but we're still looking forward to play with that. Similar system, Microsoft Direct Ben. It's RDS on steroids. It uses another FM subcarrier. It has a larger bandwidth. There is encryption. It seems very well done. I exchanged a few emails with their team, and it's promising. But there's no chance this is going to be accepted as a standard, because in Europe, they cannot get a license for that subcarrier, okay? So it's really not, I mean, it might work here, and it looks promising, but it doesn't affect us. So this was the end of our talk. I hope you enjoyed that. And then we have, I think, 5 minutes for questions. Thank you.